Let's look at some examples of conic sections in polar form. For the first few examples here, we'll look at writing. We're going to be given some information about a conic, and we want to go ahead and write out what that equation looks like in polar form. So for our first example here, we're told that we have a parabola with a directrix y is equal to 2. Sometimes it might be helpful to just kind of sketch a quick graph so we can kind of see what that parabola looks like. So I'll just do that here real quick. So we have our x and y axes, and we know the directrix is the line y is equal to 2. So that's a horizontal line above the x-axis. And I also know that the focus is at the origin. So again, the way the conic graphs work is they're always going to be a curve that bends away from the directrix around the focus. So it's going to bend away from the y equals 2 line and around the origin. So since it's a parabola, we have to have, in this situation, a parabola that opens downwards. So we have a vertically oriented parabola. And that tells us that the format of the equation we're going to use is r is equal to d times e divided by the quantity 1 plus or minus e times the sine of theta. And so being a vertical parabola tells me is that we're going to have sine in the denominator rather than cosine. If it was a horizontal graph, then we'd have cosine. All right, so to fill out this equation, we need to figure out the value for d and e, and then we need to figure out whether it's going to be a plus or minus in the denominator. Okay, so because it's a parabola, that tells me that the eccentricity, which is e, has to be 1. So that's a nice, easy thing to figure out. As soon as we see it's a parabola, we know the value of e is 1. The second part is we need to figure out the value of d. Well, the d value is whatever our directrix is. So since we have a directrix that's y is equal to 2, that tells me d is 2. That doesn't tell me the sign. That doesn't tell me whether it's plus or minus in the denominator. It just tells me the value of d is 2. And d is always going to be sort of an absolute value. The d value does not have a sign associated with it. It's not a plus or a minus. So that means we have right now r is equal to d times e, which 2 times 1 is 2, divided by, and then we have to figure out the denominator. So it's 1 plus or minus the eccentricity, which is also a 1, times the sine of theta. So are we going to have a plus or a minus between the 1 and the e? Well, whether it's plus or minus is going to match the sign of our directrix. Since our sign, since our directrix is positive, I'm going to have a plus inside the denominator. Okay, so if we wanted to simplify this, the formula here, we're going to have r equals 2 divided by 1 plus the sine of theta. So that's the polar equation for the conic with a focus at the origin and a directrix of y equals 2. All right, let's try another one. This time we have an ellipse, and we know the directrix is y equals a negative 4, and the eccentricity is a half. Well, just first, really quick, since the eccentricity is a half, just to make sure that this matches up, 1/2 is less than 1, and we know that if the eccentricity is less than 1, that is an ellipse. So that eccentricity does actually match that this is an ellipse. Okay. So let's go ahead and just sketch a quick graph of the ellipse, and then we'll try and figure out the equation. All right, so we'll draw our x and our y axes. I know I have a focus at the origin, and then my directrix is the line y equals a negative 4. So y equals negative 4 is a horizontal line below the x-axis. Okay, so that means the graph, the ellipse has to bend around the origin and away from the directrix. So since the directrix is down below the origin, our graph has to curve upwards around the origin. So it will extend down below the origin, but it's going to curve upwards and extend up well above the origin. Okay, so we're going to have a vertically oriented ellipse. So since it is vertical, our equation again is going to be r equals d times e over 1 plus or minus e times the sine of theta. So again, being vertical just tells me I'm using a sine equation. So to write out the equation, we need to know the eccentricity. We need to know the value of e, which we were given. That's a half. And then we need to find the value of d, which again, we're given d from the directrix. We know d has to be 4. Okay. In the numerator of our equation, we have to compute d times e, right? So d times e is going to be 4 times a half. And so the numerator, the d times e, is going to be a 2. And then we also have to figure out whether we're going to have a plus or a minus in the denominator. And to figure that out, again, just look at the sign of your directrix. Since my directrix is y equals a negative 4, I'm going to have a minus in the denominator. Okay, so we have everything we need to write our equation. R equals d times e in the numerator, which is a 2, divided by 1, and we already said that's going to be a minus, e, and the e is a half, and we already said it's going to be a sine of theta. So we have r equals 2 divided by 1 minus a half sine of theta. All right, that's going to be the equation for an ellipse in polar form that has a directrix of negative 4, an eccentricity of a half, and a focus at the origin. All right, let's try one more like this. This time we are looking at a hyperbola. Its directrix is x equals a negative 3, and the eccentricity is 4/3. And again, just looking at that 4/3, 4/3 is greater than 1, and that does mean that it should be a hyperbola. So that matches what we're given. Okay, so let's draw a graph real quick. So again, we'll start by drawing our x and our y axes. And the directrix is x equals a negative 3. So x equals a number is a vertical line. And so it's going to be a vertical line to the left of the origin. So x equals negative 3 is to the left of the origin. And again, we know we have a focus at the origin. So this hyperbola has to bend around the origin away from the x equals negative 3 line. Okay, so it's going to open up sort of to the right. So it has to go around the origin, but away from that directrix. Now, again, with the hyperbola, remember hyperbolas have 2 curves, right? That they open in opposite directions. So of the 2 curves that we're talking about the one that opens up around the origin. Okay, it's around the focus. Remember, hyperbolas actually have a second focus, and so there is another curve here, and it's going to open to the left. So it's going to be on the left side of the directrix, and it's going to open to the left. It should be a mirror image of the one we draw on the right, which I didn't draw the best there, but again, that's just a rough sketch. But so the key takeaway here is that we have a horizontal hyperbola. If you have a horizontal graph, then that means your equation is going to have a cosine. So our equation is going to have the form r equals d times e over 1 plus or minus e times the cosine of theta. And again, I'm using cosine this time because I have a horizontal hyperbola, not vertical. All right. So we still need to go through and figure out all the pieces. We need to know what's the value of e, which we're given. That's 4/3. We need to know the value of the directrix, which we're given. The directrix is x equals a negative 3. I can drop the sign on that, so the the d value is just 3. I then need to figure out what d times e looks like. So d times e is going to be 3 times 4/3, which you could write that as 12 thirds, or you could realize that the 3's are going to cancel, leaving us with just 4. And then I need to know, is it going to be plus or minus? Well, since the directrix is a -3, I know I'm going to have the minus in there. All right, so again, that's everything that we need to write the equation. So R equals 4 divided by 1 minus 4 thirds cosine of theta. And again, we have 4 in the numerator because that's the value we got for d times e. It's a minus because the directrix is a negative value. It's 4 thirds because that's the eccentricity value we're given. And I know it's a cosine because I have a horizontal hyperbola. All right, so let's look at some examples where we are given the equation and we want to identify what is the eccentricity, what kind of graph do we have, what kind of conic do we have, what is the equation for the directrix, and then see if we can sketch a graph. Okay, so for our first example here, we're given r equals 3 divided by 1 minus a half sine of theta. So the first part, let's just start with our eccentricity, because this is the easiest thing to figure out. The eccentricity is always the number right before the sine or the cosine. It's always a positive value. So in our case, the number in front of sine is a half. So I know the eccentricity is a half. Once we know the eccentricity, we can then identify what kind of conic we have. So since the eccentricity is a half is less than 1. And so if the eccentricity is less than 1, I know that I'm going to have an ellipse. Okay, so I've already hit two of the 4 things I need to do here. So we have the eccentricity, and I know that it's an ellipse. Next, we want to figure out the equation of the directrix. So because the equation contains a sine, I know that this ellipse is going to be oriented vertically. And if it's a vertical ellipse, that means it has a horizontal directrix because they're perpendicular. So a horizontal directrix is going to have the form y equals plus or minus d. Okay, so I need to figure out, is it a positive or negative value, and then what is the value for d. Okay, now let's start with the positive, negative value. The sign of the directrix, whether it's positive or negative, is going to match the addition or subtraction. It's going to match the sign in the denominator of our fraction. So since I have 1 minus 1/2 sine of theta, the directrix is going to be negative. So y equals a negative whatever d is. Okay, so to find d, let's look at the numerator. So in this case, the numerator has to equal d times e. In our equation, we're given that the numerator is a 3. So I know d times e has to be a 3. And I know that e is a half. So that means d times a half has to be 3. And if I want to solve that for d, I need to multiply both sides by 2. And so that means d is going to be 6. So my directrix is going to be y equals a negative 6. All right, the last piece we want to do here is just to sketch a graph. There's several ways that we could try to do this. And I've already included a polar coordinate plane here, so the concentric circles extending outwards from the origin. So I think perhaps the best way, the easiest way to figure out what the graph looks like is to just create a table of values. So kind of like doing an X, Y table. But in this case, I'm going to use theta and R. And for theta, I'm going to pick 4 values. I'm going to use the 4 quadrantal angles, basically. So 0, pi over 2, pi, and 3 pi over 2. So remember, 0 is the positive x-axis, pi over 2 is the positive y-axis, pi is the negative x-axis, and 3 pi over 2 is the negative y-axis. So it's giving me the 4 cardinal directions, right? Up, down, left, and right. So I want to take those 4 values and plug them into my original equation. So if I take 0 and I plug it into my equation, so that means I'm looking at 3 over 1 minus a half sine of 0. Okay, well, I know that sine of 0 is 0. So I have 3 over 1 minus a half times 0, which a half times 0 is still 0. So it's 3 over 1 minus 0. 1 minus 0 is a 1, so 3 over 1, which is a 3. So if theta is 0, r has to be a 3. And I want to do that, repeat that process using the other 3 values. So if I take pi over 2 and I plug it in for theta, right, I'm going to have 3 over 1 minus a half sine of pi over 2. I know sine of pi over 2 is a 1. So this is going to be 3 over 1 minus a half. 1 minus a half is a half, so 3 over a half. And if you divide a whole number by a fraction, you flip and multiply. So 3 times a 2 over 1, which is a 6. So in the pi over 2 direction, the r value is going to be 6. Then we're going to try pi. So if I take pi and I plug pi in for theta, sine of pi is 0. So I'm actually it's going to be the same process as doing the sine of 0. So we're going to get the same result, which was just a 3. Okay, because sine of pi is also 0. If I do 3 pi over 2, this will be very similar to the pi over 2 value, but sine of 3 pi over 2 is a negative 1. So if I change this pi over 2 to 3 pi over 2, sine of 3 pi over 2 is a negative 1, which makes this plus a half. And 1 plus a half is 3 halves. And then we're going to take 3 times 2 thirds, and that's going to be 2. All right, so I'm going to have a 2 here. All right. So I need to take those 4 values, put them on the polar grid, and then connect the dots. All right, so in the 0 direction, so that's to the right, we're going to go 3 units out, so to the third concentric circle. In the y direction, so in the pi over 2 direction, we're going to go 6. So up 1, 2, 3, 4, 5, 6. Okay. In the negative x direction, so in the pi direction, we're going to go out 3 units. And then in the 3 pi over 2 direction, which is down the negative y-axis, I'm only going to go down 2. Okay, so this gives me 4 points. And if you notice the point on the sort of where the positive y-axis would be in the pi over 2 direction, it is definitely further away from the origin than the others are. And so this is going to create for us, if we connect the dots, an ellipse. It's going to, if I don't draw it too well, it's almost going to look circular, but it should be an ellipse that extends vertically in the positive y direction. All right, let's try a couple more here. In our next example, we have r equals 4 divided by 1 plus 2 cosine of theta. So we're going to follow the same process. First, find the eccentricity, which is the number in front of cosine. In this case, that's a 2. If the eccentricity is 2, well, 2 is greater than 1. And if the eccentricity is greater than 1, that means we have a hyperbola. All right. Then our directrix, we need to look at, is it going to be x equals or y equals? Well, since we have cosine, that means we have a horizontal hyperbola, and horizontal hyperbolas are going to have a vertical directrix. Vertical lines have the equation y equals x equals. So we'll have x equals plus or minus d. So I need to figure out, is it plus or minus, and is it what's the d value? So it's going to be the plus or minus matches the sign in the denominator. Since the denominator is a plus, I know my directrix is going to be a positive value. And the d value, again, I can get out of the numerator. The numerator is d times e, and in this case, it has to equal 4. I know e is a 2, so d times 2 has to equal 4, and that means d has to be 2. So my directrix is x is equal to 2. All right, so let me go ahead. I didn't do that last time, but let me go ahead and draw the directrix here. So x equals 2, so that would be where the concentric circle of radius 2 crosses the x-axis. So there's the x equals 2 line. And then we want to go ahead and graph it. So I'm going to do the same thing. I'm going to create the theta and R table, and I'm going to use 0, pi over 2, pi, and then 3 pi over 2. And I'm going to just plug those values into the original equation. So if I take 0 and I plug it into cosine, that's a 1. So cosine of 0 is a 1. 1 times 2 is 2. 2 plus 1 is 3. So my radius value, my R value, is going to be 4/3. Then we're going to take pi over 2. Cosine of pi over 2 is a 0. 0 times 2 is still a 0. 0 plus 1 is a 1. And so we're left with 4/1, which is just a 4. Then we do pi. So cosine of pi is a -1. A -1 times 2 is a -2. And a -2 plus 1 is a -1. So I have 4 divided by -1, and that's going to be a -4. And the last one is 3 pi over 2. So if I put 3 pi over 2 in for theta, cosine of 3 pi over 2 is 0. 0 times 2 is 0. 0 plus 1 is 1. So 4 divided by 1, again, will be a 4. All right, so let's plot those points on our grid. So in the 0 direction, we're going to be at 4/3, which is kind of between 1 and 2. And then in the pi over 2 direction, we're going to go up 4. So 1, 2, 3, 4. In the pi direction, so this one's a little interesting. Remember, pi is to the left, right? So that's where our angle is sort of on the negative x-axis. But how do you graph a polar coordinate with a negative r value? Remember, if it's a negative r value, we're going to actually take the coordinate and flip it in the opposite direction. So even though our angle is in the pi direction, which is to the left, we're going to flip it diagonally or across the origin, and it's actually going to move to the right. So instead of going to the left 4 units, we're actually going to move to the right 4 units. And so it's going to be on that point where the fourth circle, the circle of radius 4, intersects the x-axis. All right, the last one is in 3 pi over 2. So 3 pi over 2 is down, right? So 3 pi over 2, we're going to go down 4 units. 1, 2, 3, 4. All right, so again, we have 4 points, but the directrix this time actually cuts between some of those points, and we don't want the curve to cross the directrix. It has to curve away from the directrix around the focus, and our focus is at the origin. Okay. Also, remember that we have a hyperbola, and a hyperbola has 2 separate curves. Okay? And we're actually given the points on both of those curves this time. So if we take the points at 4/3 and then pi over 2 and 3 pi over 2, right? So if we connect these 3 here, this will give us what the graph looks like for the left half, or the first piece of the hyperbola. And that's the hyperbola whose focus is at the origin. The second curve, it has to have a vertex at pi -4. So it's going to be this other 4th point on the right side of the directrix. And so again, we should have a sort of mirror image of the left half of the graph. And so that's what our hyperbola will look like. All right, let's look at one more, and then we'll be done. So this time we have the equation r equals 12 divided by 2 plus 2 sine of theta. So for this example, the very first thing that we should observe is that the leading term in the denominator is a 2. It's not a 1. And so for all of the stuff that we've been working through and thinking through, to apply here, I need that 2 to actually be a 1. So how do we change a 2 to a 1? So there's several ways we can do that. But what we want to do is take that 2 and divide it by 2. But you can't just divide the 2 and only the 2. We have to take everything and divide it by 2. So you might think of this as taking this whole fraction and multiplying a half in the numerator and a half in the denominator. So multiplying by half is the same thing as dividing by 2, right? So, and I can't just do it to the 1, 2. I have to do it to every term. And so by multiplying the numerator and the denominator by half, right? A half divided by half is just a 1. So I'm not changing the value. I'm just going to change the way our formula looks. So if I take everything and multiply it by a half, the 12 in the numerator is going to become a 6. And then the 2's in the denominator, 2 times a half is just a 1. So they're just going to become 1s. So I'm going to have r equals 6 divided by 1 plus 1 sine of theta. Okay. Now and you don't even need the 1 there, technically, the 1 in front of the sine, but I'll leave it there. So now that we have this equation written, so the leading term in the denominator is a 1, I can go ahead and go through our process. I can figure out the eccentricity, what type of conic it is, and so forth. Okay. So let's start with the eccentricity. The eccentricity, remember, is the value right in front of the sine or the cosine, which in this case is just a 1. So we know the eccentricity is a 1. And the nice thing about that is if the eccentricity is a 1, that means we have a parabola. Right? If the eccentricity is less than 1, we have an ellipse. If it's equal to 1, we have a parabola. If it's greater than 1, we have a hyperbola. Okay, so it's going to be a parabola this time. We know we then need to figure out the directrix. So since the equation has a sine in it, I know that this is going to be a vertical parabola. So it's going to open up vertically. It's going to have a vertical axis of symmetry. And so if it's a vertical axis of symmetry, it's going to have a horizontal directrix. And the horizontal lines have the form of y equals. Okay, so I know I have the equation y equals. Whether it's going to be positive or negative, and it's always plus or minus d, right? So is it a positive or negative? Well, if we look at the equation, it's 2 plus 2 in the denominator. So my directrix is going to be a positive value. So I just need to figure out d, right? And so d, I know the numerator of my fraction is d times e. So I know d times e has to be the numerator of the fraction. So here's where you want to be careful. We want to use the numerator of the fraction of the function that had the leading term of 1. So I don't want to use the original function that had a 12 in the numerator. I want to use that 6. So I know d times e is 6. I know the e is a 1. So d times 1 has to be 6, which means d is also 6. So my directrix has to be y equals a positive 6. All right, let me draw that on our graph here. So we go to the concentric circle of radius 6, and we're going to have our horizontal line here. So y equals 6. The focus, remember the focus is at the origin. The directrix is at a positive 6, and so the graph has to curve away from the directrix around the origin. So I should end up with a parabola that opens downwards. Okay. So to go ahead and graph it though, let's go ahead and let's go ahead and create a theta r table. So theta and r, I'm going to do the exact same values. So 0, pi over 2, pi, and then 3 pi over 2. So I can take those 4 values. I can plug them into the original function, the 12 over 2 plus sine theta, or 2 plus 2 sine theta, or I can put them in the simplified version, the 6 over the 1 plus sine theta. Okay, doesn't matter, you'll get the same value. Sometimes it's easier to use one or the other, just depending on if maybe there's some decimals or fractions within the big function. But this case, it doesn't really matter because I don't have any fractions or decimals in there. So I'm going to go ahead and use the simplified version just because it's simplified. So if I take 0 and I plug it into sine, right? So I have 6 over 1 plus the sine of 0. I know sine of 0 is 0, so we're just left with 6 over 1, which is 6. So if theta is 0, r is 6. If we then do pi over 2, so 6 over 1 plus the sine of pi over 2, I know sine of pi over 2 is a 1, so that's 6 over 1 plus 1, which is 6 over 2. which is a 3. So if theta is pi over 2, r is going to be a 3. If I do pi, so 6 over 1 plus the sine of pi, I know sine of pi is 0 again, so that's just 6 over 1, or 6. All right. The last one here, 3 pi over 2. So 6 divided by 1 plus the sine of 3 pi over 2. Well, sine of 3 pi over 2 is actually a negative 1. So I can have 6 divided by a 1 plus a negative 1. Well, 1 plus a negative 1 is 0. So I get left with 6 divided by 0. Well, what's 6 divided by 0? 6 divided by 0 is not a real number. We can't divide by 0, so it is undefined. Okay, so if theta is 3 pi over 2, then there is no r value. It is undefined. Okay, that might seem odd, but it should make sense, right? Because we do have a parabola and it opens downwards. So in the 3 pi over 2 direction, this parabola, this conic graph, is not going to touch the negative y-axis. It's just going to open up and continue extending downwards. So let's plot our points here. In the 0 direction, we're going to go out 6 units. In the pi over 2 direction, so that's upwards, we're going to go 3 units up. In the pi direction, we're going to go out to a negative 6. So 1, 2, 3, 4, 5, 6. And then in the 3 pi over 2 direction, which is straight down the negative y-axis, there's no point. It's undefined, right? Because again, the graph is not going to bend around, curve around, and intersect the negative y-axis. Okay, so that means our graph only has 3 points, at least of the ones that we've plotted or are determined. So the graph has to extend outwards and down. Okay, and so that's what our parabola looks like. It should be a parabola with focus at the origin, directrix at y equals 6, and its vertex is at pi over 2, 3. So this is our vertex here, by the way. Our vertex would be at 3, comma, pi over 2. Remember, when we write polar coordinates, we write them as r theta. So the vertex is at 3, comma, pi over 2. And it's a parabola that opens downwards. All right, so hopefully that shows you how we can take information about a conic and write its equation in polar form. Or if we're given the equation in polar form, we can identify sort of the key characteristics of that conic. So its eccentricity, the type of conic it is, its directrix, and then we can also sketch a graph, particularly if we create just that theta and r table.